So this is to help you with question 7 of exercise 1D in year 2 core pure further maths module. So in question 7 you had part A, then you had part B, and then in part C, that's the trickiest one, you have to find 4 solutions, distinct solutions of this polynomial of degree 4, so quartic. Okay, so this has been derived in part B, and we're going to use this identity in helping us to solve this problem. So the first thing you should notice is what has one got to do with the other. And if I look very carefully, I have 4 tan and then to the power of 1, and then 4 minus 4 tan cubed. So if I go over here, I can see I've got, over here. Let's just do it like this. I've got this one and this one. Now they are opposing signs. You've got 4x cubed minus 4x. But then you've got on the bottom, you've got 1 minus 6 of that something, which is tan squared, and plus 1 tan to the power of 4. Now you've got x to the power of 4, so that's good. You've got minus 6x squared, so that's similar, well, the same, apart from the one it has x, one has tans. So there's a lot of similarity. So what I'm going to do, I'm going to work on the principle that I can replace x with tan theta, but I'm going to try and see if I can make this equation look like this fraction. So if you carefully, first of all, what we notice that these have opposite signs. So if I move those two terms with x's onto the other side, I'll be left with x to the power 4 minus 6x squared plus 1. And on the other side, I will have 4x minus 4x cubed. And then, to make it look like this, but with x's, we're just going to divide through by the left-hand side. So if I divide by x to the power 4 minus 6x squared plus 1, I will have 1 left on this side. And over here, I will have 4x minus 4x cubed over x to the power of 4 minus 6x squared plus 1, which is the same as this, but rather than x's, we've got tans. And of course, I put x to the power 4 first. So, because we are going to, we've allowed our x to be equal to tan theta, so what it says, if I replace this over here, I will have 1 will be equal to tan 4 theta. So I need to solve that equation. Looking for 4 solutions, it's the quartic, so 4 solutions. 4 theta, tan inverse of 1 is pi over 4, then it repeats itself every pi. So it's 5 pi over 4, then we're going to add another 4, so it's 4 pi over 4 and 13 pi over 4. Divided by 4, you're going to get theta is equal to pi over 16, 5 pi over 16, 9 pi over 16, 13 pi over 16. Again, this is not the solution. The solution are x's because we are solving this equation. So x is going to be tan pi over 16. Put it in the calculator if the question asks you to find the value of it to 2-3 decimal places. Next one is 5 pi over 16, tan of that. Then tan 9 pi over 16. And finally tan 13 pi over 16. And again, the question might, I think it asks you to give your answers to 2 decimal places. Use your calculator to find the values. There you go.